All right, so we're going to continue talking about different ways to represent data. We talked about histograms, and we talked about some stem and leaf plots, and those things, while they're helpful and they do show up from time to time in IB exam, are not typically what IB is more interested in. They're more interested in being able to work with what is called a cumulative frequency graph. So what happens with a cumulative frequency graph is you're given a set of data. The data is typically continuous, like it is here, where you'll see this little table I have of weights of people and the frequency of those weights occurring. And essentially what we do is we try to then take the frequency of each one of them and make it into a cumulative frequency graph. So we add up the frequencies as we go. And then we plot them. And you get an idea of the spread of the data. You get an idea of how many people were in this sample. And then you can find things like the median and the quartiles and the percentage of people that are below a certain point or above a certain point. So you can find percentiles in those things. So it's a helpful way of representing data. So here we have weight. It's from 55 all the way up to 105 kilograms. And they're done in 5 kilogram intervals. And the frequency is just saying there's 2 people in this category, there's 3 in that category, and so on. The vast majority of people are in this range here from 75 to 90. So what we're going to do to create a cumulative frequency graph is we're going to go down here just to show you. We're going to basically create a third column. And what we do is we take the frequencies and we just start adding them together. So between 55 and 60, there's 2. And then we say less than 65, there's 5. So it's slightly different than this. We're not saying there's 5 in this interval. We're saying there's 5 that are less than 65. Then we add 12. And so we can say there's 17 people that are less than 70. And we add 14, that's the next number. And so we know there's 31 that are less than 75, and then 50 that are less than 80, and so on. And then what we can do with that data is we just plot the cumulative frequency graph. So we take and we go 60 and 2, 65 and 5. And we use the top of the range because we can say there's 5 people that are less than 65. We don't use the middle because in theory there could be somebody at 63. So we don't want to graph 5 and 62 and a half. So hopefully that makes sense to you. But we're always going to use this number and this number. So this is because we're talking, it's the same kind of idea as a histogram in terms of the x and y axis. The x-axis is whatever it is you're measuring. So the x-axis is going to be the weight, and the frequency goes on the y-axis. So I've cheated a little bit and not actually plotted it by hand, but I just took a picture from the textbook that I was using. So here is the cumulative frequency graph. So what you get is at 60 there's 2, at 65 there's 5, and so on, and you kind of go up the line. You have to be careful of your scale on this to make sure that it's going to include everybody. So what typically happens is there's not very many at the first part of the graph. There's not very many at the end. So you're going to notice this sort of S-shaped curve. And then there's a lot in the middle. So what we can do is based on this graph, we can find answers to questions like this. So the question says to use the graph to estimate the median weight. So remember the median is the middle number. So what the cumulative frequency graph gives us, first of all, is it gives us, if we go back up here, this number, this 120, that's the total number of people. So the median, if you remember in terms of how to calculate it, we take 120, we add 1, and then we divide by 2. And that tells me what the middle number is. So the middle number is the 60.5 number. So we go to 60.5, it's already indicated for us on the graph here. And then we go down and we look at what is that number. And that number, according to this graph, is 81.5. So the median, we can say, is 81.5. So that means that that's the middle number. The next thing says the number of men weighing less than 73. So what we do there, we go to 73. So that's 75, that's 70, so we can kind of go a little bit more than in the middle, go over, and we just read that number. And again, they've read it for us, so we'll take their number, but typically you're going to draw the graph yourself. So you'll have to be careful to make sure that your scale is done properly and you have a good grid or a ruler, because otherwise these numbers will be off. But we read that as 25, and we say there's 25 men that are less than 73. Then we go to the number of men weighing more than 92. So what we do is we go 92, again, we just read it from our scale. 92 is right there, and we have to go up a little bit to see where it comes from. They've read that for us as 112. The difference is here, it says the number of men weighing more than 92. So what we found is that less than 92 is 112. So that means that greater than 92 is 120. That's our total number of people minus 112. So the people that are greater than 92, there's 8 of them. So that's the idea behind a cumulative frequency graph. And what it allows you to do is find information about your data set in a different way than maybe a histogram or a stem and leaf plot. So here's another example. It says, in an examination, the following scores were achieved by a group of students. So based on these scores, it says you want to find the median, you want to find how many students scored less than 65, how many students were between 50 and 70, and so on. So the first thing we're going to do is we're just going to get another column here. I'm going to call this the cumulative frequency. So I'm just going to go CF, and I'm going to start adding. So 2, then 7, 7 and 7 is 14. You add 21, you get 35. Add 36 to that, and you get 71. Add 40, you get 111. Add another 27, you get 138. Add 9 more, and you get 147. And then finally add 3, and you get 150. So there's our cumulative frequency. So then what we have to do is we have to draw that. So what we're going to do is we're going to take our grid out. I'm going to just go in here for a second and find a grid so that I can do this properly, because I want to make sure that I have graphed this well. If I don't graph it properly, and I'm missing my grid, where is it? There it is. I want to make sure that I'm doing this properly because I need accurate numbers for my answers. So I'm going to put a grid here. I would encourage you, if you don't have graph paper, to get some for this. You don't have to have graph paper. If you don't have graph paper, what I would suggest is you at least invest in a ruler so that you can do these accurately, because what happens if you don't is you're going to end up with things that don't look really straight or that are hard to read, and when that happens, then you get numbers that are wrong. And IB is pretty picky. Now, usually they will give you grid paper. So when you answer a question like this on an IB exam, you'll have a grid, and it's 1 centimeter grid paper, and typically they'll actually tell you the scale so that everybody's supposed to get the same results. But once they've told you that, they get really picky about your answers. So just be careful as you go. So here's what we have to do. We have to figure out a scale. We have a score from 0 to 100. Nobody got less than 10, so that's good. So we're going to have to go from 0 to 100, so I'm just going to go up by 10. Here I think there's 10 spots, so that's 10. And what I'm going to do, I'm going to cheat a little bit, and I'm going to just use a straight line to make sure that's it's right. And I'm going to go, there's 1 block, so that's 10. There's 20, there's 30, there's 40, there's 50. There's 60, 70, 80, 90, 100. I might actually cut this in half. So let's go 50, 60, 70, 80, 90, and 100. It must be 20. So we'll go 10. Every 2 is 10. So there's 20, 30, and so on. You don't need to fill them all in. You can if you want to. So there's, you know, if you want to do this, then there's 40, there's 50, there's 60, there's 70, there's 80, and there's 90. If you don't want to, then I'm happy with you just putting 100 at the end and counting. Now, we've got our X scale, and that is, in this case, what we're measuring is this score. So we're going to say it's a score. Down here, we're going to label it. All right, and on here, we have our frequency, and I just usually label that with an F. I'm going to take another line to make this straight, and what I'm going to do with this, I just have to figure out, okay, what do I want for a scale on my y-axis? The biggest number I have is 150, so if I go up by, let's say I go up by 5, so there's 10, just like I did on the y-axis, there's 20, or x-axis, I mean, there's 30, there's 40, and so on. We should get up to, there's 50, 60, 70. Actually, we might not get up to 150 if we do this. No, we won't, because we need, so we'll have to go up by tens. We need to get to 150, and that won't take us there if we go up by 10. So we'll go up by tens, which means that this is actually going to be 20. This is going to be 40, 60, 80. That's 100. That's 120. That's 140. And there's 150. So we'll just mark that in there. There's my top mark. So when I look at this data, I'm going to plot 20 and 2. That's my first point. So I go down here, I find 20, there's 20, and 2 is pretty low. And then I go 30 and 7. So 30 and 7 is a little bit higher. Then I go to 40 and 14, so that's above 10 now, almost to 15. Then I go to 50, and it's up to 35, so that's a bigger jump. So 50, it's at 35 now, which is just in here. And then 60, I'm jumping up to 71, so that's here. And I'm going to go, there's 60, there's 70, so kind of there. Then at 70, I'm at 111, so I'm going to go 70 and 111. That's a pretty big jump again. There's 100, that's 110. 111, I'm going to say is right there. And then I go to 138 at 80. So 80 is up at 138. Oops, I made that dot in the wrong spot. Over one. It's hard to read this sometimes on the smart board. So 80. I'm going to 138. Okay. That's almost at 140. Then I'm going to 147. So that's here, almost to 150, and then finally I'm at 150. And what you'll notice is I get this shape to my curve. Then I try my best to connect the dots on the curve. So I'm going to kind of curve it up. And then I missed slightly, so maybe I can just grab this a little bit up ever so slightly. There we go. And the better you do this,